I almost forgot to cover that. I accidentally started getting into notes with second hour, thinking that we've already talked about the acronym circuits or ticks. And you guys don't get scared. Don't be afraid. It's not that really too tough of an idea. But, we're going to get into that. But I put this here, all right? And again, only those, well, I did this in degrees. So I did do this circle around, and we did it in degrees on Monday. Boy, that's taking a long time to open. And then, boy, it makes me worried about how my notes are going to work today. And then I color coded. And then this is only for those that watched the video on radians. We made an extrapolation that all of the over 6s were the 30, 60, 90s. Look how I color coded them in red on this sheet. All the blues are the over 4s, which end up being 45s. 45 90s. And then all the greens are the 60, 30, 90s reference triangles. Really, the only big deal with radians is fractions and being good with fractions, and then being good where these land. And I'm going to help you on this again. So I put this on. If you wanted to print on a color printer, go for it. I actually think you shouldn't. That's why I was like back and forth. Do I give them this or not? Because you will never ever have this in front of you on a test. It's not going to happen. I'll show you how you're supposed to think, though, and how you're supposed to be able to know where these radians fall. So I put this worksheet on. This is a cat worksheet. Meow. And I like the CUDA software that I use, what they did with these beginning questions. So they look challenging. Some of them are bigger than 100 or 360 degrees. Like, look at this first one. Oh, and then there's COTs. So yeah, today we are going to talk about the other 3 trig functions. Secant, cosecant, cotangent. I did bring them up before, but we're going to do trig on them, which is not a big deal. They're just flips of the ones that we know. But look at this. They actually draw this for you. So we already had questions like this where I went bigger than 360 on a worksheet. So this is negative 360 plus another negative 315. So they're telling you where this lands and how you move. It's actually teaching you. But then the next thing you do is create your triangle, right? And it's a 45, 45, 90 in quadrant 1. But look at this one. Cot, first of all. Oh, no. So they're telling you 17 pi over 6 is more than 1 revolution. And this is what we're going to get into today. Because a full revolution, put that in the chat. What's a full revolution in radians? And this tells me that you watched the video. Right? And then just put, not the symbol, but the word. Delicious. Cherry, apple, pumpkin. Nobody's going to put in the chat what 1 revolution is in radians? Nice. Those are the ones that watched the video. And then now the remaining people might just be copying the answer. All right, who knows? You never know, could you? There's another angle measure in degrees. They go ballistic on you here. They do all. Look at this one. It's because 6 pi over 3 is 2 pi. 12 pi over 3 is another revolution. That's why we see 1, 2. That's why I love this worksheet. It really makes you think. And then what's left over, we'll talk about how you find out what's there. Okay. Ooh, I'm in the way. Get out of the way, Mr. Secants. There we go. Get him. What's going on? Somebody have something to say? I heard a microphone go on. Okay, so all right. Oh, hey, look at that. We did talk about secant, cosecant, cotangent back in the day. Might want to snap out that worksheet, right? I accidentally hit that there, right? Or last notes before our test. Okay, so right here is I have nothing special planned. I'm just going to start making up questions. All right, we're going to start with a CSC. And then what did I do in the other hour? I think I did CSC of, let's say, 4 pi over 3. This is another proof. Let's do 5 seconds before you answer. It's another proof if you watch the Radians movie or not. After I do the countdown, what is the reference angle? 5, 4, 3, 2, 1, go. Look at Alessandra. Nice. Very good. And I think there's no way you could be copying it. Bam, 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 bam. So that's proof, I think, that you guys watched the video, and that's good. I like seeing those names, and I do make mental notes. Hope you're not just copying at the end there, Ethan, all the other answers. Yeah, I came late. All right. So it is a 60-degree reference angle. Okay, so off to the side, we're going to write something. Write this in your notes. So, ka, toa, because I'm going to do some stuff with this, like what I said in the, the note to myself in the calendar. So, katoa, sir kicks or ticks. What? But the first thing we got to do is this. Sine is so, cosecant is related to sine. So sine is so, cosecant's a ho. What? I mean, cosecant's H over O. I bet you never forget that now. All right? So cosecant's just the flip of those two letters. That's it. That's it. Okay? Just remember that. Cosine is ka, secant is ha. All right, so that's all they are. It's not a big deal to cover them. It's not a big deal to introduce this. And then tangents, toa. So cotangent is AO. So I'll show you what I tell my CAT students to do. I tell them to write SOCA or TOA for secant, cosecant, cotangent questions, and then just go like this. Oh, this is cosecant. Cosecant's related to so, but I got to do that for cosecant. I got to go in reverse direction, right? Okay, now let's do this question before I talk about SOCA, TOA. All right, now this is why you should not need that unit circle. And again, it was like 50-50. Do I even share that with them? Then back in the day, I spent so much time on color coding that. That is my personal, I made that, with all the colors, and so proud of myself, right? But it's a crutch, man. You're not going to get it again. So you got to follow along with what I do here. Okay, so first things first, you're severely behind if you don't know 0 radians is here, and then 2 pi lands right back where you started. Okay? So 2 pi radians is equal to 360 degrees. And then that's where the conversions come from, if you watch the video. So half of that is pi. And that is equivalent to 180 degrees. Right? So, and if you, again, you got to watch all the videos to get where all this came from, and then just move on. It really just has to happen. So in the chat, this always drives me nuts, and this is the only reason people are bad with radians. It's not radians. It's not trigonometry. It's fractions. And it's exasperating as a teacher how bad students are with fractions. It really makes me sad. So I'm going to change pi. You're ready to fill in the blank to blank pi over 3. What is the blank here? 5, 4, 3, 2, 1. Tell me. Good. It's a very simple question. It's a grade school question that Lexi Samuelis could answer. Right? Oh, I'm being rough here. It's for sure the case. And then 2 pi is blank pi over 3. What is the blank in 5, 4, 3, 2? You were too quick, Jed. No, the others? All right. 6 is the answer. So why I do that is, where is 4 pi over 3? In the chat, what quadrant does this land in? 3, 2, 1, go. What quadrant we in? Good, Emily Ann. Oh, I saw 1 in there. Everyone else put a 3. It's definitely quadrant 3. So that's the point of making this 3 pi over 3. First of all, it's a positive angle measure. It just means we go counterclockwise. And then we go another pi over 3, which is 60 degrees. Pi over 3 does equal 60 degrees. And if you don't know this, you are so severely behind, I can't even talk to you. 30 degrees, 1. 60 degrees, root 3. 90 degrees, 2. Remember, this is coordinate trig, though. -1, comma, negative root 3. Oh, negative. Okay? So the radians, you just gotta know what it really translates into to a degree measure, and then it's the same question. Okay, so what's cosecant? This is what I tell my students to do. Cosecant's related to sine, so it's H over O. Oh, I gotta label these. O, A, H. So H over O is 2 over negative root 3. I'll just equal it. And then this is -2 root 3 over 3. Okay, so you can see that second worksheet I shared, what's going on there. Love the first page. It really trains the students to understand what we're looking at here, how many rotations are happening, and then the kind of triangles that you get. Okay. Oh, and I forgot to tell my second hour. The next question I'm going to deal with is how you do the bottom of the worksheet from the radians. I'm sorry, let me see. Let me go to the calendar again. I'm getting myself lost. All the things that I've shared. Let's get rid of that. Oh, I didn't want to get rid of that. I'm going to look at that later. Okay. Unit circle homework. No, I think it's this one. It's the radians one. Yeah, it's this homework worksheet where I go back and forth between radians and degrees. By the way, did you see that says a 13.3 worksheet? That's because it's from CATS. Yow. This is taking too long to open. Come on, what's going on? What are you at, 1218? Good. Mishmash between radians and degrees. You could add the other three trig functions after this. That would be smart. So sine of -3 pi over 4, what's the cosecant? It's just the flip. And then some random questions here down at the bottom. How do I do trig of 0, 90, 180, 270? That's what we're going to get into right now, but I'm going to do it in terms of radians. But you know what we need? We need a new thing here. We need this cirkix or ticks that I was talking about. What? Stimulus, I can barely handle SOHCAHTOA. Well, we're going to have to, because in the next question, we're going to have to change SOHCAHTOA. Do look at this. Look. This is x comma y, right? Every single time you draw a triangle, the opposite side is always the y coordinate. Every single time that you draw a triangle correctly, the x coordinate is always the adjacent side. Now, where does the letter R come from? It actually comes from the word radius, because I shared with you a unit circle. All right, and then there's some, and by the way, on that unit circle, ignore the coordinates for right now. I really want you to be drawing these triangles. The coordinates do have meaning and are related to the 30, 60, 90, and 45, 45, 90, but don't worry about that right now. So if you can just remember, H is now turned into a radius for some sort of circle, then that's where SIR comes from. It just means when we're dealing with coordinates, instead of so, it can be written as SIR, because sine is always the y over the r. Cosine is kixer, SIR, because the adjacent side is always the x coordinate, and hypotenuse is now called r. And then what's tangent? Go ahead and put that in the chat. Not TOA, what is that going to change to? Let's just see if anyone's getting what I'm doing here with this acronym. Not TOA, but chat. Ooh, there's no Z. I think you mistyped there. Oh, it's flipped around. X. Oh, some people are putting XY. It's Y over X. So good. I like the attempt, but just make sure you understand that the opposite side is the Y and the adjacent side is the X. Okay, so for this question, do we need that? No. For the next question, absolutely. Because now what I'm going to do is do secant. Now I'm going to do secant of, let's just start off with something simple, 3 pi over 2, something from our unit circle. In the chat, in 5 seconds, what's 3 pi over 2 equal to in degrees? 5, 4, 3, 2, 1. Oh, not 45. Good. I like the attempt. Nope. 3 pi over 2. 45s are always over 4s. Adrian, are you just copying those answers? Not a third. No, I want the actual angle. There you go, Matt and Emily Ann. Perfect. I was looking for the actual. I think you guys were trying to do reference angles. Good, but it's not. Reference angles for 30, it's over 6s. For 45, it's over 4s. This actually equals 270 degrees. And I'm going to show you how we could do that without looking at our unit circle. We know this is 0 and this is pi. We know this is 2 pi. Half of pi is pi over 2. Oh, okay. When I'm over 2, I'm on a y-axis. That is 100% true. So anytime you see an over 2, you're on one of the y-axis, top or bottom. 1 pi over 2, 2 pi over 2, 3 pi over 2. So here's where 3 pi over 2 lands. Okay, so I just did that fractionally. You know, that's why radians, if you're good with fractions, you understood what I just did there, and Emily Ann and Kayla and Matt are proven to be true there, right? 270 degrees is what this is. Oh no, I don't have a triangle. Now what do I do? Okay, well, this is called coordinate trig. So I make up a coordinate. In the chat, there's an infinite amount of possibilities what that coordinate could be. Go ahead. And then once someone puts one answer down, you can't do that answer anymore. So what would be a possible coordinate? There you go, Emily Ann. Ooh, Dave, something's wrong with that. Now, Alessandro, I'll count yours. You came right with good. Good. 0, -6. Good. 0, -2. I think 0, -77. I like your thought process there. I think that was Jed. That was awesome. Guess what I'm going to pick? 0, -1. This is what my life easy. Good. Look at everyone still going here. So we have to make a coordinate in order to do coordinate trig. Heck, this was a coordinate, right? And I made up a coordinate that this terminal side passes through. And then I make you draw triangles so that we can play SOHCAHTOA. Okay? So yeah, this is good. By the way, R is just the distance back to the origin. So how far does it take to get back to the origin? What's that distance? Put that in the chat. And then I want to make a point. Remember when Jad said 0, -77? His R would be 77. Did you hear what I said? Anyone that put 0, -9, their R would be 9. So it doesn't matter what you choose. That's why I choose just 0, -1. And then now this is why, what? I'm sorry. It's R is always positive. Okay, so you remember what I said about you don't have a triangle. You can't do SOHCAHTOA. Cosine ka. What's the adjacent side? There is no triangle. I can't make that assessment. I can't do that. So I must do Kixer. But then secant's the reverse of that. So it's R over X instead of X over R. So you must make this transition for questions like this. If there is no other way. So yeah, in CAT, we don't even say SOHCAHTOA anymore. We say Secants or tics. Okay, so, oh no. Hey, put in the chat, what is this equal to? I always get in 5 seconds. Don't do it right away. 5, 4, 3, 2, 1, go. This is going to be so funny. Ooh, 0, 0, 0. Oh, I bet you a lot of people put 0 after that. Is anyone going to step above and beyond? Uh-oh. Somebody's got something different. Like 12 people have said 0 and 1 person said undefined. The law of large numbers, does that mean more people are right? No way. Type it on your calculator, and you will find that Matt is the one that is correct. Nicely done, Matt. Let's give him a hand. You got a few. Oh, wait, that was me. No one else gave you a hand, Matt. I guess it's just me. Sebastian, that's copying. Okay. So I get CAT students that leave this as the final answer. I'll mark you wrong so quick your head will be spinning because you're just telling me you don't know what 1 over 0 is. By the way, this is all no calculator. You would never have a calculator for this, on the test when we get back. I don't think we'll have a test right when we walk in the building again. I think we'll wait till later in the week. Depends on the timing of some other stuff. Actually, I don't even know what I'm doing. So what did I do? I did a secant, a cosecant. Let's do a cotan. Let's do cotan of, what time do we got here? 30? It's 12:30, right? Okay, so let's do cotan of -9 pi. Ooh. First of all, in the chat, how many revolutions are in there before we, how many revolutions do I have to take out of this? This has how many revolutions, then an angle measure left over? Good. Awesome. All right, and at that point, good. I think all those guys were authentic because 2 pi is a full revolution. So that is 4 revolutions right there, clockwise. So that's all the negative angle measure. It's just which way I go. Mrs. Fasola, when we were talking today, she, her dealing with her students, she asked different types of questions. Like my students really got the connection that negative angles doesn't mean negative sides. There is no relationship between that. Just negative angles are which direction you go. Negative sides are just what quadrant you land in and what is the coordinate. There is no correlation between the two. Not like that. Okay, so clockwise. 1, 2, 3, 4. You don't have to draw that, by the way, because you see how this gets in the way. But that's why I like the worksheet I gave you. It shows those revolutions. And then I don't have the time. You should know that this lands here. But I do have the time for in the chat. What is this coordinate? What am I going to put next? Go ahead. No time limit. Who's the fastest typist? What coordinate am I going to put there? Emily Ann. I had a feeling you were going to win. You were pretty fast on most of these. But Emily Ann, you didn't put parentheses. So Ethan, you win because you put the proper formatting. Sorry, Emily Ann. And then, of course, R is equal to 1. Did I do this again? I think I did. Okay, so cotan is the flip of tan. Tan is ticks, cirkicks or ticks, so it's x over y, which is -1 over 0, which is undies again. So this does happen, from time to time. And then, I could do all the rest of them. Like, what's sine of negative 9 pi? Well, I have all the information I need up there. Sine is y over r, which is 0. Cosine is x over r, which is -1 over 1, which is -1. And now this is one you can type on your calculator. Put your calculator in radians. Got to do that first. And then do the cosine of negative 9 pi, and you'll get -1. Just as a discount double check of what's going on here. And then you can do the same thing for tan, because you do have that button. Tan of negative 9 pi is 0 over -1. And you will get 0 when you type tan of negative 9 pi. All right, and then just some others. We already did cotan. So secant of negative 9 pi is -1, the flip of -1. Oh, no. And then cosecant of negative 9 pi is another one of those undies. Because 1 over 0 is undefined when you flip that. Okay? So I think we went through a lot. This does take some time for the radians. We'll probably talk about it again on Thursday. And then we'll talk about some other coordinate trig questions that I haven't done yet that don't really pertain to radians. Just little different questions in trig with coordinates. So, and then we're going to close off trig. Following week, we're going to do non-trig questions with circles. Okay, all right. I guess that's it. I had some people left. I don't know if I actually took attendance, so I'll just have to look at the meeting thing at the end. Okay, sorry I'm blabbering. See you guys.